Alaikum. Welcome everybody. Today the experiment will be the extraction, and the extraction is a technique we use it to separate a mixture of organic compounds. In principle, the main tool what we need for the extraction is what we call it the separating funnel. And in this separating funnel, as you will see during the steps, we're going to use two immiscible liquids. Actually, as you can see in your manual, the criteria for the two immiscible liquids that they shouldn't dissolve each other. And generally speaking, the two immiscible liquids, one will be water, or what we call it aqueous solvent, and the other one is the organic. And generally speaking, organic or most of organic solvents does not dissolve or immiscible with water. In this experiment, the two solvents will be the water and the ethyl acetate. Now, what exactly we are going to do and what's the purpose of this experiment exactly? In this experiment, we are going to use a mixture of two organic compounds. We have in here benzoic acid and naphthalene. Both are mixed together. Now, how to separate them? Then what this is the steps actually which will enable us at the end of the experiment to separate the two products. So let's just proceed stepwise according to the procedure. But before proceeding forward, I just would like to highlight something. As you know, both of these two compounds, they are organic compounds. They should be soluble in organic solvent, such as the ethyl acetate, as in our experiment. But the difference of the two compounds, one is acidic, which is the benzoic acid, and the other one is neutral, which is the naphthalene. In this case here, when we add sodium hydroxide, as in the procedure, to the ethyl acetate, the acidic compound, which is the benzoic acid, it will definitely be then solubilized, it will be soluble in the sodium hydroxide solution, and thus it will be removed from the mixture going to the aqueous solution. The naphthalene will never be soluble in water because we have the general rule here for solubility like dissolves like. So naphthalene cannot be soluble in water. So let's just proceed, and then in every step we will explain further. According to your procedure, we have to take 2 grams of this mixture, and in order, and always, as usual, we use the weighing boards. Here we use first the weighing board, and then we turn it to the 0, and then again here we will take approximately or around the 2 grams, but we will record the measurement precisely in our lookbook or in our notebook. All right, I have very close measurement to the 2 grams, which is almost, I will record it, so the mass of impure mixture is 1.9799 grams, which is again very close to the 2 grams, but not necessarily to be 2.000. So according to the procedure, we have to transfer this amount of the mixture to a 100 milliliter conical flask, and then we need to dissolve this mixture with 40 milliliter of ethyl acetate. So we just measure approximately 40 milliliters of ethyl acetate. And then we swirl it a little bit until it dissolves fully. It may take maybe 1 minute until it dissolves. For any reason, if it took longer than that, you may simply use a magnetic bar and a stirrer in order to accelerate the solubility of the mixture in the ethyl acetate. So in this case here, as you will see, when we dissolve everything in the ethyl state, we will dissolve both compounds in the organic solvent, which is in this case the ethyl acetate. After that, we will transfer this solvent into our separating funnel. It may take another few seconds. All right. Now, according to your procedure, we need to transfer this amount into the separating funnel, and before doing so, we need to check and be careful that the tab here is locked in order not to pour down everything inside, and simply either you add it right away, or I always prefer that we use a funnel actually in order to transfer everything fully without losing anything outside. Now, after we transferred it into the separating funnel, according to your procedure now, we will add 20 milliliters of sodium hydroxide. Now, what's the purpose of adding the 20 milliliters of sodium hydroxide? The sodium hydroxide, or the aqueous layer in this case, it is actually the aqueous layer here. As you can see, the sodium hydroxide is a base, and we have in here, we have two compounds. One is a neutral, which is the naphthalene. One is acidic, which is the benzoic acid. Now, when I add the sodium hydroxide to this solution, what's gonna happen? Simply two things actually you should notice. First of all, there will be like two layers, because simply the water and the ethyl acetate, they are not soluble into each other. Now, how can I guess which layer is which? Of course, the upper layer is always the less dense layer, which is in this case, based on the density difference, the ethyl acetate is lighter than the water, therefore it is the upper layer, while this is the aqueous layer. What we should expect here, that in this organic layer, we will have the neutral compound, which is the naphthalene, while in the aqueous layer here, we will have the benzoic acid dissolved in the basic medium, which is the water medium, and it will be like a salt of the benzoic acid. Now, in order to make the separation more effective, we need to use a stopper, and then to hold the separating funnel with my hand strongly, like this, and then I turn it upside down, and then open the tab here in order to release any vapors which has been developed inside. I repeat this step 3, 4, 5 times until I don't see any evolution of any vapors in here. So I just turn it upside down, 1, 2, 3, something like this, and then open up. And then again, I should be careful not to simply point this into the face of others, simply, and not my face even, just to be a bit far away from myself, and then just to make sure that there is no vapors inside. And at the same time, I have done the extraction more effectively. I mean, I gave enough time for the benzoic acid to transfer fully from the organic solvent into the aqueous phase. I think it's enough for the time being, so I just attach it again into the clamp, and then give it some time for the layers to develop. As you can see, if you can just focus please the camera to the layers. Now, after that, I should simply separate the two layers. Again here, I'm going to separate the lower layer here, which is the aqueous layer, based on the density difference between the two solvents. I carefully open up the tab and control the movement here until I see the layers has been separated fully. Always make sure that the stopper is not on actually, otherwise the separation will not be as nice as possible. You can see the layer is approaching, so I should be careful. All right, I made the first extraction. In order to make this extraction as effective as possible, first extraction is always not enough. So we need to repeat this at least 3 times. Sometimes we may repeat it 5 times, sometimes 10 times, based on the solubility and solubility difference. So I should add again another time sodium hydroxide. I'm not gonna repeat it many times. I have to mention this, but you have to add again 20 milliliters of sodium hydroxide, and then do the extraction again. Again, I should wait like 1-2 minutes until the layers has been fully separated, and then I separate now the lower layer again. As you can see, the layers are separated slowly but nicely. I control the whole show nicely. See the layers right here. Cannot see the layers. I must be careful actually when I separate the layers. I think still, because of the light reflection, sometimes it's difficult to recognize the layers. But in principle, what you can do for this purpose, you may use a piece of paper in order to somehow decrease the reflection and thus the layers to be more clear. All right, I think should be careful now. All right, okay, perfect. Now, at this point, as I said, you may repeat this step a few times in order to achieve the separation as perfect as possible. But for this purpose is enough to show it to you twice. So what did we do so far? Now, as you can see here, we have the organic solvent, and what's solubilized or what dissolved in the organic layer here, or in the organic solvent, we have the naphthalene, which is the neutral compound. In here we have the aqueous layer, which is simply sodium hydroxide layer. Now in this is, of course, as we know, acid reacts with the base, and therefore we should expect the benzemic acid, which was here, which was within the organic layer, it has been reacted with the base, with the sodium hydroxide, and has been converted into its corresponding salt. So we have here benzoic acid salt soluble. We have the benzoic acid dissolved in the dissolved in the water as a salt, because the water contains base. Now what we need to do in order to get the free benzoic acid, we need to acidify the aqueous layer here, or the basic aqueous layer. And how we do so, we simply have to add approximately 20 milliliters of 2 molar HCl all at once. we add it to the aqueous solution, and as you can see here, as soon as I add it in here, we have a big amount of the benzoic acid has been crystallized out. Now, generally in your procedure, you should simply check the pH of the solution after you added the HCl in order to be sure that the solution is acidic enough. But in this case, as soon as you get the solid, then definitely the solution is acidic and no need to check it out. Now, in order to get more and more of the benzoic acid, we need to minimize the solubility of the benzoic acid in water, and to do so, we need to insert or put it in ice cold water in order to decrease the solubility, as I said. But of course, we are not going to wait for long, so just showing you what we have to do. Now, of course, after that, we need to separate the benzoic acid from the water, and to do so, as we have discussed in the previous experiment, we need to make a suction filtration, and we have already arranged everything in here for the suction filtration, and then we add it all at once. As you can see here, we have separated our benzoic acid from the mixture, so we just rinse this a little bit with ice cold water, and then we insert it again. And then, of course, here we have achieved the separation. We separated benzoic acid from the naphthalene. The naphthalene stayed actually in the organic phase. Now, we are not sure about the purity of the benzoic acid. In order to purify the benzoic acid or the separated benzoic acid, what we need to do based on your procedure, you have to do the recrystallization experiment, and you have to follow the steps as we have done the previous time. And finally, in order to check the identity of the benzoic acid, what we have separated from the mixture, you need to determine the melting point and the melting point rate. With that, we are done with this experiment. Thank you for listening. See you inshallah next week.